Welcome back to the deep dive. Our mission today is to figure out the shortcut you need to understand how animals navigate a world that is, well, constantly throwing sensory noise at them.
Exactly. Every creature, from the tiniest insect up to a bird, has to combine information from multiple senses. It's something called multisensory integration.
But here's the real challenge. What happens when the environment changes dramatically? Say you move from a quiet forest to a loud, polluted city. How do you decide which sense to prioritize?
Right, which sense gets the promotion and which one gets sidelined?
That moment of decision, that cognitive shift, is what this deep dive is all about.
It is. We're zeroing in on a super adaptable species, the great tit, or Paris major. This one study gave them a test, basically, asking them to find food using either sight or smell or a combination of both.
And crucially, they compared tits from natural, quiet forests against those living in these, chemically complex and noisy urban areas.
And the big takeaway we're hunting for is how the environment itself, things like pollution, city clutter, and even things like whether the bird is male or female, can force this dramatic top-down shift in their whole cognitive strategy.
This isn't just about behavior, is it? It's showing genuine mental flexibility.
Oh, absolutely.
Yeah.
The setup was really elegant. They took wild-caught great tits and trained them to associate a multimodal QSO, a specific color paired with a specific odor, with a food reward.
A tasty mealworm, I believe.
The best reward. And once the birds were trained, they ran the critical test, the Q separation. The birds could choose from 4 food spots. One had the full package, color and odor.
The multimodal cue.
Yep, then one with only the color, one with only the odor, and a control with nothing. The choice they made tells us everything about which sense they trust the most.
Okay, let's unpack the setting and the players. Why the great tit? What makes them such a perfect model for this?
Well, great tits are ideal because they've successfully colonized cities all over the world. But they still have really robust populations in their original forest habitats. They're generalists, but they've adapted incredibly fast to city life.
So you get this perfect natural experiment.
Exactly. And the researchers found a really strong contrast for it in Sweden. The urban birds were captured around the city of Lund.
And the forest birds?
They came from Hur, which is about 30 kilometers away, much more rural. And, you might think the difference is just more buildings and traffic noise. But the source material makes it clear we are talking about profound chemical changes in the air.
That's a key distinction. This isn't just like a leafy suburb versus downtown.
Not at all.
So give us the data. What kind of sensory pollution were these city birds dealing with?
The urban sites in Lund had really significant pollutants. The yearly averages for something like nitrogen dioxide, NO2, were around 18 micrograms per cubic meter. And for fine particulate matter, those P10 particles, it was about 15. Now, compare that to the rural sites, where those levels were consistently under 5.
Wait, just to stop you there. For listeners who don't spend their lives reading air quality reports, how significant are those numbers? Is 18 micrograms enough to, really notice?
Oh, yeah.
Because if a bird is relying on smell, you'd think that kind of chemical noise would be a huge problem.
You absolutely hit the nail on the head. Those urban numbers are high enough to be clinically significant for human health. So for an animal with a refined sense of smell, it's major chemical interference.
So conventional wisdom would say what?
It would say that this constant chemical noise should impair their sense of smell. It should make olfaction way less reliable than sight. And that expectation is really important because it sets up the big surprise later.
It certainly does. So, okay, let's go back to the standard playbook. If we just ignore the pollution for a second, what did the researchers expect to see based on this idea of multisensory integration?
Well, based on other foraging animals, especially insects like bees, the expectation was that the combined Q-sight and smell together should create a synergistic effect. The signal gets a higher salience.
Meaning it's just more attractive, it pops more.
Exactly. It's a bottom-up process. The signal itself is so strong that it should speed up learning and make the bird's response way more efficient. They really thought the multimodal cue would be the overwhelming favorite for all the birds.
And before they could test that preference, they had to make sure the birds could actually learn the association in the first place. How did the training go?
The training was very successful. They used specific color-odor pairings, like blue, yellow, green, with distinct smells like vanilla or methyl salicylate. And the birds got it pretty quickly. They went from about 61% correct choices in the first session all the way up to a really confident 85% by the end. They definitely knew which combo meant food.
But with wild animals, you've always got to worry about motivation, right? What about a bird that just wasn't in the mood to play the game that day.
They planned for that. They used mild food deprivation, up to 2 hours, for any bird that seemed a bit unmotivated. And that was a crucial step, methodologically. It ensures that any differences they saw later were about cognitive strategy, not just a bird that would rather be napping.
Right. It levels the playing field.
It does.
Okay, so that sets the baseline. Now for the main event, the cue separation tests. Looking at all the birds together, did they confirm that standard integration hypothesis? Did the combined cue win big?
Well, they confirmed that all the cues worked better than the control, which is good. The highest preference was for the full multimodal cue, chosen about 31% of the time.
Okay.
But here's where the hypothesis starts to crumble. The single-sense cues were right behind. Visual cues were chosen 28% of the time, and olfactory cues were still picked 23% of the time.
Hold on. 31% is still the highest. Why are we writing off the idea that two senses are just better than one? Couldn't that narrow margin still be, marginal proof that integration works?
It's a fair question. But the stats just didn't support that idea of a synergistic jump. If it was true, bottom-up integration, the preference for the combined cue should have been way stronger than for the single cues.
A lot stronger.
A lot. And even more telling, they looked at the very first 5 choices the birds made. If that multimodal cue had genuine high salience, that bottom-up pop, those first choices should have been overwhelmingly for it. And they weren't.
Interesting. No difference between early and late choices.
None.
So what does this tell us? If they're not getting this automatic synergistic boost, what cognitive strategy are they actually using?
It suggests they're doing something we call sensory prioritization. And this is a much more active top-down strategy.
So instead of the signals just merging automatically.
They are actively focusing their attention on the sense that, based on their experience or the context, seems most reliable. It's all about modality appropriateness, voluntarily deciding, okay, in this situation, sight is my best bet, or no, smell is more accurate right now.
And that shift from automatic processing to an active strategic choice, that's where it gets really interesting. Which leads us right to the biggest surprise in the study, how their habitat totally dictated that prioritization.
This is a truly remarkable finding. It just flips conventional avian wisdom on its head.
Okay, lay it out for us.
When they broke down the data by where the birds were from, the patterns completely reversed. The forest birds behaved exactly as you'd expect. They strongly preferred visual cues.
Makes sense. Forest environments are visually dominant.
Right. They chose the visual only and the multimodal cues at a similarly high rate. For them, sight is king.
But the urban birds, the ones surrounded by air pollution?
The urban birds showed a strong preference for anything with an odor. They chose the olfactory-only cues and the multimodal cues almost equally. This flies directly in the face of the idea that NO2 and particulate matter should be impairing their sense of smell.
Instead of being impaired, they chose to rely on it.
They doubled down on it.
So why? Why would a polluted, visually cluttered city cause a bird to deliberately prioritize its nose over its eyes? It sounds almost like a risky move.
The sources offer 3 really compelling hypotheses for this, and they all point back to strategic adaptation. The first is adaptation to urban visual heterogeneity.
Meaning the city is just visually chaotic.
Exactly. Think about looking for something tiny in a city versus a forest, especially in winter. The city is full of visual noise traffic, buildings, ads, flashing lights. The visual contrast for a little piece of food might be way lower.
So sight becomes the unreliable signal, and smell, even with the pollution, is actually steadier.
Precisely. The second hypothesis is all about the food source itself, tracking anthropogenic food.
Human food.
Yep. City birds rely heavily on human food scraps, feeders, garbage. And those things often give off strong, consistent chemical signatures. So prioritizing smell could be a super efficient way to track down those scattered, high-reward food items.
That makes perfect evolutionary sense. If the city provides reliable smelly cues, the smart bird learns to follow its nose.
And the third hypothesis points back to flexibility itself. It might be that urban birds are just, in general, more exploratory, more behaviorally flexible than forest birds. It's a trait you'd need to survive in an unpredictable city.
So they're better at learning new tricks.
They might be. This flexibility could let them shift their attention, that top-down driver to smell, simply because their experience in the city taught them that smells were the most reliable indicator of a meal. The city literally selects for the bird that can learn to trust its nose over its eyes.
That alone is just a fundamental shift in how we see urban survival. But if the habitat split wasn't surprising enough, the study found another split based on the bird sex.
hmm
How did males and females use these cues differently?
This part really highlights the role of precision. The female great tits showed a very distinct, clear preference for the multimodal cues,
So the full package.
the full data set. They wanted the color and the odor together over either one alone.
And the males.
The males were less discriminating. I mean, he clearly preferred any cue over the control, but they foraged almost randomly between the multimodal, the visual, and the olfactory options. Their preference wasn't nearly as sharp.
So it suggests a difference in the cognitive need for accuracy. Why would the female insist on that double cue while the male is more casual about it?
It's fascinating social ecology. The sources connect this right back to social hierarchy. In the great tit world, males generally dominate food sources. They have a higher social rank.
So they can afford to be wrong more often.
Exactly. They have a greater margin for error. If a male makes a mistake, he can often just muscle a lower-ranking bird, like a female, off a different food source. The stakes are lower for him.
So if he checks the wrong hole first, no big deal. He'll just intimidate his way to the next one.
Right. But for the female, a mistake carries a much higher cost in energy and time. She has less guaranteed access to food, so she has to be a much more precise and observant learner to maximize every single opportunity she gets.
Her strong preference for the full multimodal cue, then, is about seeking maximum certainty.
Yes, the combined signal reduces ambiguity and guarantees the reward. It makes her foraging hyper-efficient, which she needs it to be.
It's a powerful connection. We're not saying males are lazy learners. We're saying their social dominance allows them a margin for error that the female, under greater selective pressure, just cannot afford.
It forces her to be more cognitively precise. And it shows that this whole sensory prioritization thing isn't just about signal strength or where you live. It's heavily influenced by these top-down factors: attention, experience, and the specific pressures tied to your social rank and sex.
So, to synthesize this entire deep dive, we've learned the great tit is an incredibly flexible cognitive adapter. It prioritizes its senses strategically based on context.
Right. Urban birds lean on smell, despite pollution, because the city's visual noise makes sight unreliable.
And within those groups, females use multimodal cues with remarkable precision, a strategy likely driven by the intense pressure of having a lower social rank. It's a clear win for flexible, top-down sensory prioritization over that automatic integration model.
This study is so crucial because it forces us to reevaluate what we focus on in urban adaptation. We talk a lot about noise and light pollution, but this really highlights the ignored role of avian olfaction and chemical pollution.
It shows the city isn't necessarily just ruining the great tit's senses.
No, it's forcing the bird to become strategically smarter about which sense to trust and when.
Which leaves us with a pretty fascinating final thought for you to mull over. If a bird's sensory priorities are so finely shaped by the specific level of noise and pollution in its neighborhood, what happens when that neighborhood changes faster than the bird can adapt? At what point along that urban gradient might their finely tuned foraging strategies finally fail? If the city changes how they sense the world, what else might it be changing about their long-term survival that we haven't even thought to measure yet?